Hello everyone, welcome to video AML lab session. In this session, we will be discussing the second lab program, that is implementation of AVO-star search algorithm. So this is the program code. So here we are instantiating the graph object with graph topology, heuristic values, and start node using these statements. Then we have definition for apply AVO-star function. So then this is the definition for the get neighbors function. So it gets the neighbors of a given node, and this function will return the status of the given node. So next, set status function. The definition of set status function is here. So it will set the status of the given node. Next, we have a heuristic node values function. It always returns the heuristic value of the given node. And here we need to set the revised heuristic value of the given node. So next, this piece of code is to print the solution. So we have definition for compute minimum cost child nodes. So this piece of code is to compute the minimum cost of the child nodes of the given node B. So here it iterates all over the set of child nodes. So here it initializes the minimum cost with the cost of the first set of child nodes. So then using this statement, it will set the minimum cost child nodes. Then here using these statements, the code will, we are checking the minimum cost nodes with the current minimum cost, and then we set the minimum cost child nodes and return minimum cost and minimum cost child nodes. This statement is to return the minimum cost and minimum cost child nodes. So this is the definition of the AVO-star. So this AVO-star algorithm, it is used for a start node and backtracking status flag. So next, here in this section, it will check if status node V is greater than or equal to 0. And then it computes the minimum cost nodes of V. And so here it will check the minimum cost nodes. Check the minimum cost nodes of V are solved or not. Next, we have this statement where if the minimum cost nodes of V are solved, it will set the current node status as solved of -1. Next, it will update. So here it will update the graph with the solved nodes. So it will update the graph with the solved nodes, which may be a part of the solution. Next, it will check the current node. It will check the current node. Current node is the start node for backtracking the current node value. So here it backtracks the current node value with backtracking status set to true. So next it will check the current call is not for backtracking. Next, for each minimum cost child node, it will set the status, and then it will set the status of the child node to 0, which is required for exploration. And then minimum cost child node is further explored with the backtracking status as false. So this is the heuristic value provided for the graph, nodes of the graph, and this is the definition of the graph. Here we are using two graphs. This is the definition of, the nodes contained in graph 1 and the weights of each each edge between two nodes. Next, here we are calling the apply AO star function. The definition of this function, it is here. This is the definition of apply AO star function, which in turn calls the AO star function. So this is the heuristic value for the nodes of graph 2 and definition of graph 2. So finally, it will print the solution using print solution function. So this is the output of this program. Thank you.